Okay, so now it's started. And this being the 30th of October, what we're going to work on today, I've put in your class notebook. You should be able to see it under any of these, but I put it under the Chapter 3 tab. And this is examples for Chapter 3, Lesson 4, all about perpendicular lines. You should also be able to see it in the content library under Chapter 3. But I guess it didn't go. There it is. It's under here. I must have entered that wrong. Okay. So if you want to open up your notebook now, go ahead and open another tab or whatever you need to do. Or you can open it in Word or as a PDF if you're going to write on it. For my purposes, I printed it out so that I could, do it in color and stuff like that. But if you want to print it or try to write on it, do it now. Okay. We're going to do all about perpendicular lines, and I'm going to go ahead and switch to my camera now. Okay. So we're all focused. We're good. I am assuming that you've already watched that 12-minute video from yesterday that tells us all about these theorems. But like I said, now we're actually going to do work. So our lesson objective is that students will be able to, wait, first, you know what I should do? I should put my name on here. All right, so students will be able to find the distance between a point and a line, and also apply theorems about perpendicular lines. So also in the video last night, I introduced that symbol. It looks like an upside down T. That means perpendicular because nobody wants to spell out P-E-R-P-E-N-D-I-C-U-L-A-R every time. So we just write that symbol. So the distance from a point to a line, this is, you have a line at any point. This distance is the length of the perpendicular segment from the point to the line. Again, this perpendicular segment is also the shortest distance. And that's what's going to be important here. It is the shortest. So say I have a point here, any point. Well, you can draw a line straight down that's perpendicular. But any other line that you draw, whether it's here or here or here, they're all going to be longer. And the reason they're going to be longer is because that if you make like a, this is not working with yellow. If you make like a right triangle out of it, if you recall, the hypotenuse is always longer. So any other path is longer than the perpendicular one is. Hopefully you can see that. Like I said, we're going to do a couple of problems where they ask you to find that shortest one. And so the first thing we're going to do is find the distance from A to BD. So the first thing I'm going to do is I'm going to figure out where A and DB is. Okay, so here's B and here's D. And then A is over here. So if we apply that theorem, that means that really what we're looking for is this right here, because that's the one that's marked with a perpendicular. So what we're really looking for is the segment AC. Now I'm going to write A over here because it's hard for me to see on the grid. And then C is 1, -1. The way we used to do the distance formula is we would write that AC is equal to the difference of the x's squared plus the distance of the y's squared. So if you don't recognize this as the distance formula, it is also what you should recognize as the Pythagorean theorem. So what you do is you pick one of these to be the first one and one of these to be the second one. It doesn't matter which way you pick it, as long as you call them the right thing. So I'm going to pick A to be the first point. That means that's x1 and that's y1. I'm going to pick C to be the second point, and so that means x2 is 1 and y2 is -1. Those little subscripts don't mean anything other than labeling this the first point and the second point. And then you just plug them in where they go. So we have that AC. So x2 is 1. x1 is -3. So I'm going to go ahead and make it +3. y2 is -1. And y1 is 3. And so now that you have numbers in there, you can figure out what they are. So this is going to be 4 squared, which is 16. And then this one's going to be -4 squared. And -4 times -4 is also 16. So the square root of 32 is what we're down to. Now, I need to simplify it a little bit more. And so for those of you who don't remember how to simplify square roots, you look for the factors of 32 and you try to find the biggest factor that is a perfect square. So what I'm thinking is that this is equal to 16 times √2, because then I can change root 16 into 4. So I'm going to come over here, and AC is equal to 4 times the root of 2. And this is what we call an exact answer. It is that, it is exactly that, there's nothing more. But if you did want to approximate it, okay, if you wanted to approximate it, then you could do square root of 32, and you get 5.66. We put a squiggly, remember? Because it's not exactly that. I chopped it off, I rounded up, but that is an approximation. So you know how picky Big Ideas Math is when you try to enter something that it doesn't like maybe it wants 5.7, maybe it wants 5.65 something. So I would always go with the exact if it were up to me, because I don't have to pull out my calculator. It's a whole extra step. So any questions right now about these? I'm looking for your hands since I'm looking at the work on the camera. Okay, so we're going to do another one. Same work, less talk. Okay, so I want to find the distance from A, which is up here, to CB, which is here. That means I'm looking for, and this looks like point D. So A is -1,8. D is -4,2, because that's the perpendicular. So that is AD. I'm just going to go straight to the equation, see if I can plug these in. So I know that I'm going to do the difference in the x's squared plus the difference in the y's squared. Okay, so I'll do -1 minus -4, the x's, and I'll do 8 minus 2 for the y's. Now I can just do calculations. So this will be -1 plus 4, so that's 3 squared. And then this is going to be 6 squared. So that's 9 plus 36. Okay, so this is going to be 45. And I'm thinking about all the factors of 45. The biggest one I can think of that is a square is 9. So this must be 9 times 5. Because I'm going to change that into a 3, which again, this is my exact answer. And if I did want to pull out my calculator and do the square root of 45, then I'd get 6.71. Approximate. So any questions right now? And I am going to put a box around my answers. You know, I always like to do that. I am done. I am correct. I have checked my work. Bam, I'm good. Okay. So I guess I'll go on. If I don't have any questions, it is a review from Algebra 1. So hopefully that has all gone cha-ching in your brain. All right, so now what we're going to talk about is the linear pair perpendicular theorem. And before we do that, let's make sure to abbreviate transversal, we're going to use the word transv. Because if you do trans, that makes me think of transitive. So if you don't want us to use the word transitive, make sure you put a V at the end if you want to abbreviate transversal. Okay, now, the perpendicular pair theorem says, or the linear pair perpendicular, if two lines intersect to form a pair of congruent angles, then the lines are perpendicular. There's no other way you can get two angles that are the same measurement to form a perpendicular. And that's called the linear pair perpendicular theorem. In other words, that's how you can abbreviate it in your reasons. So that's why we highlight that. Okay, we're going to do a proof. First thing we're going to do is read through it. We're given that angle 1 is congruent to angle 2, so I can see that they're marked that way. Great. What we want to prove is that G is perpendicular to H. So I want to prove this right angle. I want to prove that this. So if I want to prove that this is perpendicular, how can I prove that that is a right angle? Like what do you need to have to say you have a right angle? So I'm trying to help you guys figure out, how do I get a right angle? What do you need to have a right angle? Anybody speak up, just unmute yourself.
Two congruent angles.
Two congruent angles will not give you a right angle. Good try. What will give you a right angle?
They both equal 90 degrees.
You need 90 degrees. Very good. you need 90 degrees. So the thing is, if you can figure out that you need to show me that angle 2 is 90 degrees, if you can tell me that angle 2 is 90 degrees, then you're home free. Okay, so if you have an idea of where you want to get to, then you should be able to start. But I can always start. Vincent, what do I always put on the first line?
Given.
I'm going to write the given down first. Okay, so angle 1 is congruent to angle 2. Now the next thing I'm going to do is I'm going to think to myself, there's nothing I can really say right here from this other than that they're the same. But when I look at the picture, what do I know about angles 1 and 2? What do they form? Angle 1 and 2, what does it form when you look at that picture?
A linear pair?
It is. Thank you, Echo. It's a linear pair. Okay, so if it's a linear pair, then you know what I can say for the next one? I can say that these two add up to 180 degrees. Very good. And the reason is that linear pair is supplementary. Now, the way you guys are all just learning how to get to proofs here and how to go next, but I can't get anything else out of that picture right now. I wasn't even given anything else up here. So then what I'm going to do is I'm going to look at these, and is there anything I can do here? Well, there is. I know that 1 is congruent to 2, and I have 1 here and 2 here. And I want to show that 2 is something. So, you know, what I could do is, how about I substitute? I'm going to substitute because these two are equal. I'm going to say that the measure of angle 1 plus the measure of angle 1 equals 180. So like I took that from here and I substituted for that. Now this is the part where I'm hoping some of you are getting to thinking. I want to get to where I have an angle equal to 90 degrees. And right now, I have the measure of angle 1 plus the measure of angle 1 equals 180. So what could I do next? What can I do? That's the question. I've got a bunch of postulates, you've got theorems. What can you do with this line to get to the next one? Just take a guess. The worst I could do is say no, but you might be right. Looking at the screen, do I have some guesses? And this is the hard part about proofs. You're learning what to do next. You have no idea what to do next. Okay. So it doesn't look like anybody's volunteering. And I don't want to call on anybody and put you on the spot. But what I will do is ask you this. I have two things. Apparently they're the same and they're equal to 180. So let's just pretend there's no angle 1. Let's say it just said m plus m equals 180. What would you do? I know you know this. So if this said m plus m equals 180, somebody speak up. What would you do?
Mrs. Payne, I think someone is raising their hand in the chat.
Someone's raising their hand.
Mm-hmm.
Okay, I can see a hand now. Faria, is your thing not working? Just unmute yourself and tell us.
Would you do measure of angle 2 plus measure angle 2 equal 180?
Oh, see, that's a good guess. But does that help you get closer to 90? It doesn't help you get closer. But it's a great guess, and that's what I was hoping to hear from people. Kate, you want to try?
Would you use the linear pair perpendicular theorem?
Okay, so we're actually not ready to use that theorem yet. We don't have, well, I guess we have that. We're actually trying to prove that we can use that theorem. So, and that's good. You're thinking. Shira, what would you say?
Would you divide 180?
Now you're thinking. What would you have to divide 180 by?
2.
You'd have to divide it by 2. Well, I don't have a 2 there to divide, but what I do have is 2 of the same thing. Can't you add them together? I think you guys are thinking too hard. There's 2 of these, so you know what I'm going to do? I'm going to add them together. Because I'm just going to simplify that. Can't you add those 2 angles together? Now, Shira, what can I do?
Divide.
Now is when I can divide. I'm hoping you can all see that. Because you have 2 times this thing, we'll call it, 2 times this angle equals 180. But if you divide both sides by 2, what property says we can do that? Don't we have a property that says that it's equal if we divide both sides by the same thing? The division property? Now, for those of you who said, could I substitute angle 2? You could have gotten the same result only with measure of angle 2 equals 90, right? So you could have done it the other way with angle 2. But now that I have that one of these angles is 90 degrees, doesn't that mean it's a right angle? You're all supposed to say yes. And now we can say that G is perpendicular to H because perpendicular lines form 90-degree angles. See why it was so important to think about where I needed to go first? I really, really need to know, okay, what does this mean? How would I get to this proof? I needed a 90 degrees. So even if you couldn't see all the steps, you at least could figure out, see, she sort of went backwards. Well, can I divide 180 somehow? Because I got to get to 90. So very good. And I love that Kate and Echo and Shira were volunteering. It's really hard for me teaching this way because I want to ask you, like if we were in the classroom, I'd say, hey, you, give me your answer. But I don't want to put you on the spot and make you embarrassed either. So going through these proofs, you're going to get better at it. Any questions right now before I turn the page? Okay, good. So we have some time. And now you can use that theorem. So whoever wanted to use that theorem, now you can use it since we proved it. Okay. Now we have a perpendicular transversal theorem. And what this one's going to say is that in a plane, if a transversal is perpendicular to one of the 2 parallel lines, then it is perpendicular to the other line. And again, we're going to be able to abbreviate it by the perpendicular transversal theorem. So if you get a perpendicular plane to parallel lines, then it's perpendicular to the other one. Meaning if you're given this perpendicular and parallel, then what that proves is that you also get this. So that's kind of handy. Now here's our little picture. It's telling me that P is parallel to Q, so I'm going to do my little parallel symbols. And it also says S is perpendicular to P, so I get this for free. And what I want to show is that that's perpendicular. Again, what do I need here to show that S is perpendicular to Q? What does he want to get to? What did we need on the last one? To say that two lines are perpendicular. Normally you guys are a little more talkative than this. You need a 90-degree angle. So what we have to do is go from here somehow to get to where that angle right there is right. Hopefully you see that. I know you're following along. So what I'm going to do is I need to refer to these angles somehow, so I'm going to number them. I'm going to put 1, 2, 3, 4, 5, 6, 7, 8. I'm just going to go ahead and number them that way. And I will tell you, this should be 5 steps. So 1, 2, 3, 4, 5. And I'm doing this because I wrote too big on my last sheet, and then I didn't have enough room. So now for sure I'll have enough room. Okay, Cabin, what is my first step?
Given.
It's always given. So we're going to write that down. So we get that P is parallel to Q, and we've got that S is perpendicular to P. Now, if S is perpendicular to P, see how I marked that with a right angle? We're now going to state that angle 2 is a right angle. The reason we're going to say that is because perpendicular lines form right angles. Now, this is the tricky part, but this is where I want you to be thinking. So I'm going to lead you down this path, and you're hopefully going to try to follow. So I now have that angle 2 is a right angle, but I need something down here to be a right angle. Because if I can get any one of these to be a right angle, then that means that this line has to be perpendicular to that. If I know this is a right angle, do I know any of these are a right angle? I have parallel lines. Can I now get congruent angles? All right, I have the same people volunteering, but I feel like I want to ask somebody else. What's one of our parallel line theorems that has to do with 2 that will give me another angle that is congruent? So I'm still only seeing 2 volunteers. Oh, Kate just took her hand down. Because you don't want to volunteer anymore, Kate? Shira still has hers up. Okay, so either one of you, tell me, what do you think?
Angle 6.
2 and 6. Yes, you can do it that way. Angle 2 is congruent to angle 6. Why can we say that?
Because they're corresponding angles.
That's it. Corresponding angles are congruent. Because we did get parallel, and that's our transversal. How about, so now I have 2 congruent to 6. And so what does that mean about 6 if 2 is a right angle? Kate, fill this in. 6 is what?
6 is a right angle.
Yep. So, and that is that all right angles are congruent. So if 6 is a right angle, doesn't that mean it's 90 degrees and we can say that S is perpendicular to Q? You can go straight from here to there because if you have perpendicular lines, then you get a right angle. If you have a right angle, then you get perpendicular lines. It goes both ways. If you have the arrows on both ends, you get both. Isn't that nice? I think that's nice. Okay, so there's your proof, and we can now use the perpendicular transversal theorem. You could have also done it another way. Did anybody think to use alternate exterior angles? Like you could have done 2 is congruent to 7 by alternate exterior angles. It didn't have to be corresponding. Corresponding is the easiest, but just different. Okay, I am going to fill in just one more sentence. We only got to there from angle 3, but if you're filling this out with me, okay, the line perpendicular to a transversal theorem says in a plane, if, I should say if 2 lines are perpendicular to the same line, this is just like the parallel one, then the 2 lines are parallel to each other and both are perpendicular to each other, to the transversal. And of course you can now do this. Okay. I'm also going to ask you to fill in, because we're almost out of time, but I am going to tell you this is a 4-step proof. So I want you to try to get it on your own. I have more examples for Monday because I was hoping to get through all of this. But look, if you could already fill this in, you could fill in 1 and 1 and 4 because you're going to get this here. You can start. And S is, so we have 2 perpendiculars, we have given, we're going to get to here, and then I'm going to leave that blank for now because we only have another minute or 2, and we filled that out, and then we'll do number 3 on Monday. Okay. Yeah, I think that's where we'll stop because I knew we'd have 2 videos for this section. It is big. And then, you know, if you have any questions, I'll be putting this video in the stream. It'll show up. So if you want to watch it again, if you missed anything, then of course, that will be available to you too. Of course, I always upload them to my YouTube channel as well. So I'm going to stop the recording.